In this video, we'll be looking at how we can approximate a truck's fuel economy at a specific moment in time. If you have ever driven on an interstate highway, you have probably seen semi-tractor trailers. These trucks often try to maintain a constant rate of fuel consumption by driving slower uphill and faster downhill. But what would happen to the truck's fuel economy if it tried to maintain a constant speed? We're going to consider a semi-truck driving along a highway with some hills and valleys. We'll use this picture to represent the truck's trip. Watch the truck driving along the highway and think about what might be happening with its fuel economy. There are several measurable attributes of the truck's trip which we might be interested in. One of them is the amount of fuel it has used since it started driving on the highway, and another is the distance it has traveled since starting to drive on the highway. I'll show the truck's trip again, this time adding a red rectangle to represent the amount of fuel it has used, and a blue arrow to illustrate the distance the truck has traveled since starting to drive on the highway. As you watch, think about how the length of the blue arrow is growing in comparison to the length of the red rectangle. What can we say about the truck's fuel economy exactly when it has used 0.2 of a gallon of fuel? To compare how the amount of distance traveled and the amount of fuel used were growing, we can measure each of these quantities. I'll show how the amount of fuel consumed increases again, and mark off 0.1 of a gallon intervals to measure it. I'll also use arrows to show the amount of distance the truck travels in each 1/10 of a gallon fuel interval. Each fuel interval has an amount of change in fuel, in this case 1/10 of a gallon. Also, each distance interval has an amount of change in distance. In this case, all the distance intervals have different sizes. Now, let's think about how these fuel intervals correspond to the distance intervals. These black lines indicate how each distance interval corresponds to a fuel interval. So for each successive 0.1 of a gallon fuel interval, the size of each distance interval changes. So now back to the question, how can we figure out the truck's fuel economy when it has used exactly 0.2 of a gallon of fuel? The general method is to use an average rate of change over an interval to approximate the instantaneous rate, right at 0.2 of a gallon. In this case, we'll use an average rate of fuel consumption over an interval of time to approximate the Using this interval, we can find the average rate of fuel consumption immediately after the 0.2 of a gallon mark as 3.6 miles per 1/10 of a gallon. This rate, 3.6 miles per 1/10 of a gallon, or 36 miles per gallon, is an approximation of the rate of fuel consumption right at the 0.2 of a gallon mark. Now we have two approximations of the fuel economy at the 0.2 of a gallon mark. Unlike before, we don't immediately know that one of these average rates is an underestimate or overestimate of the instantaneous fuel economy. To figure this out, we need to think carefully about the context. Right at the 0.2 of a gallon mark, the road is flat. Right before the 0.2 of a gallon mark, the road is a downhill. This tells us that the truck should be traveling further for each gallon of gas. And this tells us that the average rate of fuel consumption right before the 0.2 of a gallon mark is an overestimate of the instantaneous rate of fuel consumption at the 0.2 of a gallon mark. Right after the 0.2 of a gallon mark, the road has a bit of an uphill. This tells us that the truck should be traveling a smaller distance for each gallon of gas. This tells us that the average rate of fuel consumption right after the 0.2 of a gallon mark is an underestimate of the instantaneous rate of fuel consumption at the 0.2 of a gallon mark. And this tells us that the truck's rate of fuel consumption right at the 0.2 of a gallon mark is some value between 36 miles per gallon and 48 miles per gallon. If we subtract these two approximations, we can measure the precision of our approximation. Here, we know that we have approximated the instantaneous fuel economy to within 12 miles per gallon of its actual value.